Hello everybody, my name is Sally-Ann Spence and welcome to the dig here at Cerney Wick. Now we are on the Hills Quarry dig site and it's absolutely incredible because we have material from both the Ice Age and the Jurassic. But with me now is paleontologist Nigel Larkin. And Nigel, we're going to be talking about other things than just the fossils we've been bringing up, but it's good to have you here.
Good to see you.
And you're on the dig just for a little while and then you're going away and coming back again.
Yeah. I'd like to be here for the full dig, but of course I've got a real job to get back to.
Yes, what are you off to do?
Well, I'm an ex-curator for museums, but I conserve and curate and mount specimens for museums. I do it in a freelance capacity. I run my own business, so I mount specimens all the way up to the size of elephants and T-Rexes.
Oh my goodness, that's quite a large thing. I know recently you've been doing a whale at some point, weren't you?
So many whales, yes.
Yeah.
In fact, one of my next jobs this autumn, I've got to mount from scratch a 13-metre long live whale. So I do all the blacksmithing, welding, as well as all the cleaning of the bones, the conservation, etc.
Oh my goodness. So you actually know your way around a skeleton incredibly well in that case.
Well enough, yeah.
Yeah, so...
But it's not just skeletons in paleontology.
Well,
There's lots of other interesting things to be found. That's one of my passions.
Absolutely, this is the interesting thing. We have so many fossils coming from the Kellerways material. So there's an area down in the quarry which is known as the Kellerways Formation, and in that there's a lot of Jurassic material, and we're bringing a lot of fossils up. But you are absolutely brilliant because you want to talk about not just the fossils, but what we can understand about the animals, the creatures, the environment, and everything from other fossilised
the things they leave behind when they were alive. It tells you a lot more about how they interacted with their environment and how they moved.
Oh, come on,
so
tell us about it.
Trace fossils are what is left behind by animals during their lifetime. Classically, it's things like footprints, droppings, burrows, things like that. But there are a lot more trace fossils out there to be found. And we'll look at a few of them. I don't have every kind of trace fossil known to mankind and humankind, but I do have a fair representation here. So if you want, we can just crack on.
Let's have a look.
Classic. This is a classic. So this is a dinosaur footprint from near Whitby. So you've got the heel and the 1, 2, 3 toes. Oh, yes. So that tells you that, well, you don't have any dinosaur bones really up in Yorkshire. You maybe got half a dozen, though people have been looking for hundreds of years for dinosaur bones up there, but you find thousands upon thousands of footprints. Now, footprint in isolation might tell you that particular dinosaur was there, and we can tell the type of dinosaur. So for instance, that was a fast-moving, medium-sized predatory dinosaur or carnivore, but you get stegosaur footprints, you get all sorts of footprints up there from the different groups of dinosaurs around at that particular time. But when you get more than a footprint, or when you get a trackway, you can look at, stride length. That tells you something about the speed at which they were moving at that point in time. Okay. With other reptiles, you might get, for instance, rhynchosaurs and other earlier reptiles where they drag their tails as well. You might get a trackway with a tail drag mark. And there's a fantastic specimen at Cardiff Museum where you've got a trackway of several footprints from a medium-sized reptile from the Triassic before the dinosaurs. You have the tail drag mark, but if you look really closely, there's lots of other tiny little footprints there as well. Oh. So it's nice to think of that as a little family group of reptiles. You've got the large one, you've got the little ones going higgledy-piggledy all over the place. But actually, it might be that large reptile was hunting those small ones because you can't tell the difference in time. Sometimes you know that things happened at that same instant, sometimes you get overlying footprints of other ones, and so you don't know whether that happened minutes beforehand or days beforehand. So there's a lot of interpretation that has to go on. You get other, this is another footprint, this is of one of those earlier reptiles. Okay, I'll just grab a torch. This is known as a chirotherium. So what we have here is an entire footprint. Oh my goodness. It's very special because you have all 5 digits, you've sort of got a thumb-like thing there. Yes. But look at that, you have skin impression there, and then you've got 1, 2, 3, 4 other toes. These are the claw marks of those individual toes.
Look at this, I'm going to point it out because I can see it really clearly, and I hope you can on the camera there. There's one here with a claw mark. That's amazing. Another one here with a claw mark. Another one here with a claw mark, and then another one here with a claw. Yeah. That's absolutely stunning.
And these individual fingers or toes that you can see, there's actually the fleshed out outline of that animal, of the toes of that animal, but also this skin impression. You'd have to look at it under a microscope and much better lighting than this, but there's skin impression all the way along. But there in particular, if I can just move this around so you can see, amazing. You've got the little knobs and bumps of the skin. So it's not just a footprint on its own, it's telling you about the texture of the skin of that particular animal. So this was alive long before the dinosaurs, this particular reptile.
So how long roughly?
Oh, I'd have to check.
We're talking
many millions of years before the earliest dinosaurs.
And we have the skin impression there. That is so that's incredible.
Good. And then on a much smaller scale, you have things like trilobites. So these live at the bottom of the sea. or the ocean, and they scurry around in the mud, and they leave behind these little trackways. This is a small slab, you can get huge slabs of this, and sometimes there's a lot more three-dimensionality to these. They have a lot of relief to them. This one's quite flat. But you can imagine these little beasts just crawling around over that, leaving these traces behind in the mud. So you know they were there, even if you don't find the fossil itself of the animal, you know that it was there. A bit like these trackways, we don't find the dinosaur bones up in Yorkshire, but the dinosaurs were absolutely there in their thousands and over millions of years. But even better than a trackway is something called a mort ichnia. That's a death track. That's when you have the animal, there's a trackway, and then you have the dead body at the end of that. And that's fantastic fun.
That tells you just about everything. Yes.
Yeah. But there's a famous case where there must have been a pterosaur carrying a horseshoe crab. Oh, I've got one here, a horseshoe crab. Imagine that being carried by a pterosaur, dropped into a lagoon in what is now Germany. That lagoon, unfortunately, was under anoxic conditions. That means there's not enough oxygen there for the animals to live. So this poor horseshoe crab rights itself, because it was dropped the wrong way up, wanders along in a straight line, then it goes off at a bit of a curve, and then it goes round and round in a circle, because it's getting very dizzy, because it's getting starved of oxygen, it's suffocating, and then it ends up dead at the end of that track. That was a 12-metre track, and if people want to look that up, Dean Lomax wrote the paper on that and described it. That's a fantastic specimen.
And they actually have the whole story of the last part of its
the last
life,
few minutes
including
of its life, including when it arriving, which can only have been dropped by a pterosaur really from above, all the way around, suffocating, poor thing, and dead at the end. A mort ichnia.
That's actually quite incredible, isn't it?
Yeah.
That's an amazing thing.
And then we have burrows. So to me that looked like worm cast when I picked it up, but actually this is the wrong way up. If I turn it over, you actually have mollusks on that side, bivalve mollusks living at the bottom of an ocean, presumably, or the bottom of a shallow sea anyway, and they're burrowing into the sediment with their fleshy parts to get their food. So the burrows that they made are actually on that side.
So this is telling us so much about the environment they're in, their behaviour, you know, how, like you say, how they're feeding, potentially then what might they be feeding on.
Exactly that. And we'll come to that with the coprolites as well. But it also shows you they're quite gregarious. They like living together. It's not one in isolation, but a whole group.
Yes. So I was going to say it fleshes out the bones from the past.
It does, well, it does. It does literally that. This fleshed out the bones, you know, when you get good skin impressions like that. In fact, I should have brought over, Mark Kemp found a fantastic block on the Yorkshire coast of skin impression from a dinosaur.
Well, we might be getting Mark.
Yeah.
I was going to say, keep watching the videos. The hashtag is Tussforce, but we will probably be getting Mark over to talk about some of these things. Oh my goodness, what have we got coming up now?
What we have here, just on the subject of
look at this.
Animals leaving traces behind with their feet, etc. This is a slab from the River Severn, a fairly well-known site for horseshoe crabs. So what we have...
Horseshoe crabs in the River Severn?
Yes, a long time ago. Not
ago.
Currently, yes. So this is from the late Triassic. So again, quite a while before the dinosaurs. See this sort of little semicircle here? Mm-hmm. It's well known for horseshoe crab remains, that site. So that little plastic horseshoe crab that I got from the internet fits perfectly, because this is life size, on this slab. So you've got several of these little semicircles
I can
here.
see them now. You've
so
them out. Yes.
So this is where they've burrowed into the sediment. They're feeding on all the little invertebrates that are in the sediment and leaving these traces behind. And sometimes you do actually get trackways and then one of these impressions where they walked along and then burrowed into the sediment. But I don't have an actual trackway. A lot of these marks are probably to do with them wandering around, but I don't have a nice clear track yet. I'll keep on looking, because that would be nice to have. Oh, put that down.
Wow.
But there's even more exciting things than trackways, fantastic though they are. So I have quite a large collection of fossil poo.
Right, okay, and that's got a special name, hasn't it?
Hobby. Yeah, fossil poo, fossil droppings, they're called coprolites.
Coprolites.
And believe it or not, there used to be an entire industry called coprolite mining over in the east of England, where there were whole beds, geological formations of phosphatic nodules, which if you grind up those phosphatic nodules, they're great for fertiliser. So they were collected in their thousands and thousands of tons and employed thousands of people in East Anglia. Little railways were built to transport all this stuff.
Well, that makes sense, because you've got all these animals that have been on the planet for this length of time.
Yeah.
If they're eating, they're going to be defecating. So, yes.
However, they called it coprolite mining. Most of them aren't coprolites. A lot of it's just phosphatic nodules. And so it's an early example of hype, if you like. Some of them were coprolites, a lot of them weren't, but they still did the job. They were phosphatic nodules that they would grind up and throw in the fields. And so there's even Coprolite Row in Ipswich, and there's stained glass windows in the church, I think in Ipswich, somewhere in Suffolk, where they celebrate the coprolite mining industry. And there's whole books being written about it. But anyway, looking at individual coprolites, they are really valuable because they can tell you what animals have been eaten. You know,
Yes.
when you find just a skeleton, if you're lucky, you find a complete skeleton, there's stomach contents left. And you can see that they've been eating a particular type of fish or squid or something like that, because they're squid hooklets. But you can actually find droppings that you know who made them, more or less. So this is a classic turtle dropping. Very, very squiggly.
It's a lovely shape, I have to say. There's no
Yeah.
denying that is
Yeah.
a dropping.
And so by looking at modern analogues, like crocodiles, turtles, things like that, that were around millions of years ago but are still around now, you can look at the shape of their droppings, which means you can identify the ones that you find in the fossil record.
Yeah, definitely.
So this is a turtle, but it's very useful because, you know, if that was on a pavement, I used to be a curator of geology and we do workshops and things, so you talk to children about this kind of stuff.
Children
And
would love this.
oh, they love it anyway. Get the coprolites out, they're suddenly paying
Yeah.
attention. Anything scatological. But getting across fossilization can be difficult. You take something that's clearly was once really soft like that and you bang it on the table. I'm careful which specimen I do that with.
Yes.
That gets across something very soft being able to be turned to stone just through being buried for millions and millions of years and becoming mineralized.
It is absolutely amazing to think of that, though, isn't it? That something so soft can be turned into
Yeah.
rock without its shape being changed by pressure or anything.
Sometimes they could be flattened, but all the ones you can see here, they've got great
Yeah.
three-dimensionality to them. So that's a classic turtle dropping. We have some here that might be large fish droppings. We'll get this one out. That's a thing of beauty. You can see that that particular animal, it coils its droppings as they come out. Now you do get sharp
yes.
droppings that are almost corkscrew
You
shaped.
see it here, it's like a
because of
croissant.
the way it comes out of the backside of a shark, it goes through a spiral valve, and so you get classic spiral shape. So again, you say, right, we might not have shark remains because sharks are mostly cartilaginous, they don't survive very well, but you find their droppings, so you know they were around.
Brilliant. Brilliant.
One of my favourites here. This is a large
huge.
crocodile dropping from Africa. That is quite big, but that's crocodile poo shaped, so we know that that's from a crocodile. Often you can find fish scales, fish bones, squid hooklets, things like that. There are some marine reptile droppings where you actually get entire vertebrae, maybe 3 or 4 or 5 vertebrae in a row, you know, partially digestive remains of a section of an animal. We have one here that shows that you can polish what something's left behind. I reuse the word. Now I picked this up on the Isle of Wight. This looked like it was just a nodule. And I picked it up because here you have the imprint of a plant stem, and I thought, why would there be
my
the imprint of a plant stem?
goodness.
But that's dropped from a certain height and gone splat. But I cut it and polished it.
That is absolutely incredible. There is, as you said, the imprint of a plant stem. Look at that. So yes, as you said, this animal's produced it. It's landed on the ground. And there it is.
Yeah. And so that's presumably from a dinosaur, that's from the Isle of Wight. And a lot of people find droppings on the Isle of Wight, coprolites, no fossil ones,
Yeah.
and they say, I found a dinosaur dropping. Well, there's a lot of crocodiles around as well. But it's difficult to differentiate between the crocodiles that were there and the dinosaurs that were there. There's work to be done there to try and sort those out.
Right. Yes.
And
makes sense.
yeah, I'm working on that with a colleague. We also have hyena droppings, so spotted hyena, these are from Norfolk.
Right.
This is an absolute classic shape for a spotted hyena dropping. It looks like a little bun or a sea urchin. Excuse me, but it's got a little dimple on the underside. That's because there will be another one coming along behind it. And yeah, these are about 650,000 years old. Fairly well mineralised. That's to do with the deposit that we found them in. And we have hyenas in the UK for the last 1 million years. Up until about, I don't know, something like 14,000 years ago. So, and we'll come back to that in terms of the sort of thing that hyenas do. These are fresh hyena droppings.
I was going to say, this one
So
looks
actually,
rather like. I was going to say, I'm going to get that
yeah,
one out
you
as
can
well
get
if
a
I
double
may.
one. These are, I say, relatively fresh. I collected these in 1998 from the hyena enclosure at Balham Zoo because I was studying droppings at the time, specifically of hyenas. But I bring them to a site like this because we should have hyenas here at Cerney Wick, or they would have been here 240,000 years ago.
We've got plenty of prey,
Yeah.
you know, things coming out of the quarry there. Lots and lots of prey animals, and at present, not a huge amount of predator evidence.
Yeah.
So,
Well, there is some scavenging. Some of the bones do have gnaw marks on, and I'm hoping that we will find droppings that are like the smoking gun of hyena presence, if you like. Because hyenas are top predators, there's fewer of them around, so you won't find the hyena bones necessarily, but we should find evidence of them being here.
oh, that's interesting because I mean, and these are. I was going to say these are very hard droppings.
Oh yes, well, because hyenas, they devour the carcass entirely, they will eat the bones. And so they're the only animal really that does that. So they eat all the bones, there's all that mineral content in what they've eaten. They have very strong jaw muscles, very strong teeth, very strong stomach acids to deal with that. But what comes out of the backside of a hyena is almost pure powdered mineral bone, which means they survive in the fossil record, which is excellent for us, because that means we know they were there. Along with all the chewing that we find, the marks of their scavenging the bones.
Well, they are just stunning,
and I bring these to sites so that people can get their eyes in, know what to look for, so hopefully they'll find them down there.
That's a brilliant idea. We have lots of students here from a lot of universities across the UK, and a couple are from abroad too. So, not all of them have done field work before. In fact, that's the beauty of this dig, isn't it? Getting people to do field work. Yeah. So having, someone like Nigel coming along and bringing things along that they can actually see, it helps them no end when they're down in the quarry as well to get there.
Because in particular, people are looking for bones and hand axes, but there's more to be found down there than just that. So it does help.
Yes, definitely.
A few more coprolites before we move on to other things. There's a place on the River Severn called the Bone Bed. It should be called the Poo Bed, because every single bit in here that isn't grey is fossil poo, coprolites. There's a place called Orst on the River Severn, and you've got some nice ones on the top here. And then the rest around the periphery of this block are in cross-section.
Well, as you say, the fact that they've got all these different bits of prey inside them, so something that's eating other animals, is brilliant, because it's telling us so much more about the ecology of the time, the temperatures and everything else. With the plant eating, though, you're saying you don't really get much in there because it is plant material.
It's just this one, is clearly from a herbivore. It's just a swirly mass, but it's still beautiful swirly mass. That it can't be anything else other than a coprolite. And some larger coprolites from marine reptiles, say down in Lyme Regis, you find them quite commonly there. They will have identifiable bits and pieces in them. But also, with micro CT scanning these days, it's not just what we see on the surface. You can micro CT scan a coprolite and actually see exactly what is in there. And some really good work has been done with that recently.
So brilliant.
This again from the River Severn, but from a different site. You've got crocodile poo, and then a whole load of bones that could be Pachystropheus, or looking at the talk last night, there could be even coelacanth bones in this block as well, that have been recently described. They used to be described as Pachystropheus. That's work that Jacob's doing.
So every night on this dig we have people coming in. We invite students to talk about their research projects. We invite them to talk about their particular niche interest within paleontology or even archaeology. And also we have experts like Nigel coming in and giving everybody a talk too. So there's a lot goes on in this dig, not just the digging that's going.
I spoke for an hour and a half on Monday night about these trace fossils.
Do you know what,
we're trying to rattle through them today.
You could speak for them a lot.
I will now hand you one of your favourite specimens.
I love this. I absolutely love this one. So you're going to tell everybody about this.
So this, I hardly ever buy fossils, because what's the point? I like to find them. This is one that I saw in an antique centre, just labelled as Moroccan sauropod coprolite. So the large dinosaurs with the long tails and the long necks. This is definitely coprolitic material, but I bought it because they hadn't noticed this little red bit here. This is a burrow going into the dung. So that could be a type of dung beetle, some other insect, I don't know. Sally-Ann might have some ideas because she's an expert in that kind of thing, obviously. But there's even tiny little ovals in that red mass there, which are either larvae or eggs or something like that. So that's a lovely interaction telling you that that particular type of insect or beetle was around at the same time as that particular dinosaur.
Yeah, we definitely need to have a good look at this. We know that dung beetles were in existence in the Cretaceous period, so as a fully formed beetle, so very exciting.
It's lovely to have that kind of interaction.
Absolutely.
I'll put that one back. One more thing related.
You could leave it with me if you want.
No, I'm not leaving that with you, because I'll never see it again. Oh, two other things. I'll come to that one in a moment. These show another interaction. These ones, it might be difficult to see on camera, but these are coprolites from the Jurassic, which is nice enough, but if you see those tiny little grooves there, that's evidence of coprophagy. That means eating poo. So there are some animals that specialise in that, apart from the dung beetles, obviously. Do they eat it, or do they just burrow into it?
No, they're eating it as well. The larvae, both the adult and the larvae will be eating it. So well, they do today anyway.
So they are coprophagous, but these are from a marine environment, so presumably these are fish. Now they're either gnawing on the coprolite to get some good material out of there, because there is sometimes good stuff to be had from poo, or if these have been knocking around for a while on the shallow ocean or shallow sea floor, they may have algae that's grown on them. They might actually be grazing the algae off the surface of the poo.
Okay.
But anyway, that's two for the price of one. You've got two trace fossils there. coprolites and feeding traces. What we have here is kind of related. I'll hand that to you.
Okay.
That's a very, very shiny pebble, but on the surface is a little smattering of pyrite.
So I don't understand then in that case. Can you explain to us why is it shiny and yet it's so rough?
Exactly. And that's why I've identified it as a gastrolith. So gastrolith means stomach stone. Now, dinosaurs, they don't chew like we do. Mammals chew, reptiles, like dinosaurs, they chomp and then swallow. And some dinosaurs have quite primitive teeth, some of the herbivores, and so they swallow a huge amount of material, but they then need to process it further in their stomach to get the goodness out of that food that they've just eaten. And so they pick up stones, they swallow them. We know that birds do that today. Birds are dinosaurs. Famously, emus do that. There's lots of old Guinness adverts that people like us will remember, younger people might not, where the emu's got things lodged in its neck, like pint glasses, etc. So anyway, we know birds, some birds, pick up stones and swallow them to help process their food. Dinosaurs did that as well, obviously much chunkier stuff. So this is a stone that's been picked up by a dinosaur, swallowed, processed food in its gut. We know that it's so shiny and nothing else in nature produces that very high polish, but it's then been passed out the backside of the dinosaur. And we know that because it has this smattering of pyrite on the surface, and pyrite can form in those very, very, very organic conditions around something. So for instance, with marine reptiles, if they get pyrite decay, which is a whole other subject, the pyrite decay might start in their stomach area because there's all that very rich organic material in that part of the animal. And so when I found this on the Isle of Wight, there's a layer of very, very fine clay. So you've got to think, why is there a stone in what is otherwise very fine clay? How did it get there? It's not the right sort of transport to get the stone there. Why is it highly polished? Nothing in nature produces that kind of polish. Desert conditions can sometimes polish, but it has a sort of pitting to it as well. And then you have that smattering pyrite on the top. So those three things tell me that that's definitely a gastrolith. And greater minds than mine have found these things and said they're gastroliths, so we're on safe territory.
Well, this is all detective work we've got going on here.
Yeah. You've got to look out for odd things. If there's anything odd in the sediment, pick it up, take it home and wash it. I mean, for instance, this coprolite here, I didn't know what that was when I picked it up. I just thought that was a weird shape. It was rolling around at home for a few years, and I thought, no, I'll section that and see what it is. Fantastic, it's a coprolite. So it's always worth picking things up, taking them home, washing them, having a good think about them.
That's fantastic.
So poo related, but not coprolite, but a gastrolith.
And if you find anything exciting, please do contact your local natural history museum or anything, don't you?
Yes,
and take it in, get someone to have a look at it. There could well be a paper in this at the very least, or just general research.
Yeah.
So what else have we got then? Is this another coprolite?
We'll come to that. Just on a related note, jumping the gun. Just one last thing. Sadly, I don't have an example of it. That's regurgitate.
Okay, regurgitate. So that is vomit then.
Kind of. It can be vomit. It can be, if owls, they don't vomit,
do they? Pellet.
They bring out a pellet. It's the same kind of thing. They bring out a pellet because they've eaten lots of rodents. They can't really process the bones. They bring out a pellet of fur and bone. I don't know how they do it, but they're there. That then drops to the ground. And, it's a fun thing for people to do, is pull apart the owl pellets and identify the shrews and the voles and the mice that are in there. But they can be preserved in the fossil record, particularly in caves. We think there's pterosaur vomit, regurgitate rather, on the Isle of Skye. People are working on that. Tiny little mammals that they're finding, all sort of curled up in a ball, and it might be that pterosaurs were actually regurgitating and leaving these things behind. But also in marine conditions, you have marine reptiles like ichthyosaurs, plesiosaurs, apparently mosasaurs as well, according to a talk last night, where again they might vomit up the hard parts that they can't digest. And so sometimes you find a splatter of belemnite guards, for instance, in a V-shaped formation where basically the animal's gone there. But if you find something that sort of formation, it's not necessarily regurgitate until you look at it underneath a microscope and you see whether the stomach acids have etched the surface. That's the real clincher.
Okay.
And then you say, yep, that's probably regurgitate. Sadly, I've yet to find some.
It's just amazing what has been preserved in our fossil record, isn't it? I mean, this is just incredible, mind-blowing.
Even rarer than that.
Right.
But similar to all of this, there's something called a urolite.
Now, urolite, I'm presuming urea, urine.
Yep. So when you leave something firmer behind, like poo, you can find that as a thing. A urolite is where something is peed, past water, however you want to say it, and it makes an impression on the ground. Imagine muddy conditions that you're in, or sandy conditions, that liquid coming from a height of it, so quite a large dinosaur maybe, making a bit of a trough, a splatter, etc. If that then gets baked in the sun and then covered over, that can then be found millions of years later, and that's a urolite.
Do you know what? That is absolutely blows me away. I can get coprites, Eurolites. That's just a whole other level, isn't it?
Something on the list to be found. Eurolites and regurgitate.
Wow.
Enough
There's
about
a whole
bodily
other world
functions.
out there. You're right. Okay.
So
this is not a coprite then.
no,
I keep
it could be
looking at
mistaken
the
for one.
snippet.
Yeah.
Come on then,
So
tell
move
me
on
what
to
I've
this.
got there.
So we're going to talk about weather now and how weather can leave a trace in the
Okay.
fossil record.
So weather.
This is something called fulgurite. It's very, very delicate, very glassy.
There we are.
So imagine, well, we have thunderstorms, we have lightning now. If a lightning strikes in the desert, the power of that superheats the sand grains and turns it to glass, and then it makes this hollow glass tube, but it's a very rough tube because it's all sandy.
Turn it around so you can see.
And then it gets so hot you get plasma coming out of the top, which means that it's hollow. That gets sort of ejected, if you like, but it leaves behind these very fragile glassy tubes. So that's fossilized lightning strike. And there's another example here from a different context. It looks a bit like a straw. This is actually from Sally.
So it's sort of like
Sally Hollingworth. She gave me that one, which is very kind of her for the collection.
melted the silica in the sand,
Yeah,
isn't it?
so you can see
That's
it's hollow.
incredible.
Hopefully from that, well, that end, yeah. So no one would necessarily think that you could have lightning left in the fossil record. And you can get some really big ones. I've seen some this sort of size. Although you've got to be careful because some people buy them. There could be several that are just stuck together to make it really big.
Yes, that's another conversation.
Yeah.
The fakery that goes on in fossils. That's another podcast. Right. Okay.
So that's lightning. We don't have thunder, sadly, just lightning.
We can assume there was thunder though.
Yeah.
With that one.
Yeah.
Yeah.
Look at this one next, because this is another sort of very brief moment in time. This is a slab of Triassic sandstone. Maybe if I get the torch on this, it'll come out better. So this is from before the dinosaurs. And see these little craters? Hopefully you can pick
I
that
can
out.
just see them. Look, if we
Yeah.
keep the torch there, can you see
Yeah.
these? Just 1, 2, 3, 4. In fact, there's loads. You can just see them everywhere.
These are raindrop impressions. So desert conditions, a brief rain shower, then it gets baked in the sun, those little raindrop impressions are left. And some people are astonished at that, and they say, how do you know it's raindrop impressions? Well, firstly, again, greater minds than me have written papers about this many years ago. In fact, Darwin knew about this site and corresponded about it. And after a rainstorm, if you're just walking down the road or you're on a beach or something, you will see raindrop impressions in mud and in sand. And I've actually got quite a library of photographs that I take of these things, so that you can compare them to what you find in the fossil record. So that's a brief moment in time. God, 300 million years ago, 250 million years ago, something like that. I forget the exact age, but it's from the Anisean of the Triassic. I remember that. But just coming back to this footprint, this beast, this Chirotherium, was wandering around during one of these little rain showers, because you can actually see
Oh my goodness
raindrop
me.
impressions on this as well, just by the sort of thumbprint,
you
and I say
can.
thumb in inverted commas.
Yes, you can. You can just see up here and things. You can see them.
Yeah.
There is so much information locked in these. As you say, the mindset with fossils is to focus on the ammonite, the Trisanosaurus bone, the shark's tooth, the megalodon, all that sort of thing. And yet, actually, there's a phenomenal amount of information in these.
Bring the animals to life. You're looking at a
Yes.
dead animal, otherwise it's just a dead animal, it stands there. They can be fantastic, but we can think about how they actually lived their lives and how they interacted with one another and how they interacted with their environment as well, the things that were going on.
And the whole ecosystem's here.
Some of it.
Or some of it, yes. That's true.
A few more things to do with weather.
Right.
So we have this stone here. It just looks like a stone. I talked about weathering in the desert a moment ago, that it can polish stones. This is slightly different. I found this in the desert in Oman, and I was actually looking for these at the time. Well, it was a day off, so I was looking for them. It's not why I went to Oman. But anyway, this is a pebble in the desert, and look at the sort of sides it has on it. It's a bit unusual. Just see if I put the torch on there again, so people might be able to see.
Here?
So this side here on the front, that's facing the camera at the moment, that is showing the direction of the prevailing wind at that point in
Oh my
Oman.
goodness, you're not
So-
telling me this is actually showing us wind
Yeah.
and the direction it was
It's
coming in.
fossilised wind, if you like.
My
So
goodness.
we can tell that the main direction, I'll have to put that down, was this side here. The second direction of the prevailing wind was this side here, because that's the second biggest, and then the third one was here. So there's 3 prevailing winds at that particular point in Oman. Now you can find this in the fossil record. This is relatively recent. That could be thousands of years old, I don't know. But that tells me something about the wind direction in Oman. You can find them buried. So if we found them, it's not really the right conditions here because it's a river channel. But if we were looking at an ice age environment where it's an ice age desert, where it's very cold, hardly anything's growing, and so you've got a lot of sand being blown around. That's a thing for the ice ages, get these big deposits of loess, all this wind-blown sand. If you find that buried, that might tell you the prevailing direction of the wind at that point in time. Now, it could be knocked by a mammoth or a rhino and turned over, so you don't necessarily know that that one stone will tell you. But if you find more than one, and they agree with one another, then the prevailing wind was coming from that particular direction, and then the secondary wind and the tertiary wind, etc.
That is amazing, because we are using things like rocks and the wear on them and the way bones have washed up against them. In our river channel down here, we're looking at the change in the soils as to how wide the river channel was. You know, that you
How
absolutely
the river
get.
channel moves as well. The river channel leaves a deposit behind, but then later on it will cut into that deposit, and then cut into it again with slightly different, because the energy changes. So depending on the season, in fact, we talk about the seasons. Depending on the season, there's different water flow velocities, if you like. So a very low river flow will give you clays and fine particles of sand, etc. The much higher river velocities, maybe during summer when there's a lot of ice being melted, etc., you get all the gravel and maybe boulders coming downstream. So looking at the stratigraphy, looking at the superposition of those elements, you can work out what's happening seasonally maybe in the springs and rivers.
It's incredible. It's incredible how much information we get beyond just those bones and basic stones.
Keeping with weather, in a way, and ice ages.
Right, well, we've got an ammonite here. I can recognise
Beautiful
this.
ammonite, look at
right?
that. It's one of the best ammonites I've ever found. You've got the lovely mother of pearl on there still.
It's beautiful.
It's a thing of beauty. And so I'm happy just having that as an ammonite. But it can also tell us something else as well. So many things have stories to tell. This ammonite I found in Norfolk, but it's not indigenous to Norfolk. It didn't come from there originally. We know from the particular shape of this and the ornamentation that it has that this is from the Jurassic, maybe from up near Whitby, so quite a bit further north from Norfolk. But I found it in glacial till.
Okay.
It was poking out of the glacial till on the beach at Haysborough, and we can talk about Haysborough later if you like, to do with other trace fossils. Poking out of the glacial till, now that's the material that the ice sheet left behind, the very earliest ice sheet during the Anglian, something like 550,000 years ago. So that's been transported in an ice sheet. Might have taken tens of years, might have taken hundreds of years, might have taken thousands of years, transported by ice from Yorkshire all the way down to Norfolk. So that's a trace fossil of ice movement.
That's, again, stunning.
Known as a glacial erratic. It's an erratic because it's something that's out of place. And we know how it got there because it's in the glacial till. You can actually tell where the glacial till got from. If you look not just at that isolation, but all the other things in that glacial till. Sometimes there's a Norwegian component because the ice sheet from the north of England and Scotland met up with an ice sheet coming from Norway. They combined all the material that they're taking along that they then deposit in the glacial till.
All the story just where it just doesn't stop, does it?
No,
All that happens is that you just end up asking more questions, which is great because it gets the mind buzzing. We like that. I've always said that the more I think, the more I've learned, the more I've realised how little I know.
The more questions you have.
Yes, definitely. That is just brilliant. Well, we've got some other things. So we're going to
just a few more.
pass up there. Right, what would
We'll
you
look
like
at the
me to
ripples
pass?
next. That'll be nice and quick. So you get fossilised ripples and fossilised mud cracks. So this is, I think, in Penarth down near Cardiff in Wales. Lovely ripples left behind by maybe intertidal area.
There's no denying that, is it? I mean, it's just
so you've got ripples,
superb.
but then those ripples have dried out so much that they've cracked. And then this is the infilling, because of course we're looking at the opposite here. This is the negative left behind. It was actually this way up, so those cracks got infilled. But oh look, we've got ripples on this side as well, going in a different direction. You might need the torch on that. Don't know whether that helps.
See.
But they're not as good on that side. But interestingly, they go in a completely different direction. So you get ripples and mud cracks. And I do have a fossil at home that I collected. I didn't bring it with me because it weighs about 45 kilograms, I think.
This is the
And I
downside
brought
of
enough.
fossils.
Yeah. But that is a slab of fossilised ripples. Again, it's from this site actually, from the Upper Triassic. And across those ripples, you've got this little footprint trail of a rhynchosaur skipping through the wet ripples. You could tell it was wet because there's a splattering of the mud either side of the footprints.
Oh, it's just
very
these
cute.
incredible moments frozen in time. It's just, it's fantastic. Right, where should we go next?
The bone.
The bone?
That bone.
Okay.
That's from the Cromer forest bed in Norfolk. I
Right.
collected many years ago, so this has a few tales to tell. So again, I'll be happy if that's just a bone. I love finding, bit of mammoth. Take that home. Thank you very much.
So this is mammoth with...
And we know because of where it was found, that would be steppe mammoth.
Okay.
So we know the species.
So that's
We
one
can
of
tell
the
by
species
shape.
we're finding here at the quarry.
Yeah, so, but this is much, much earlier. This is about 650,000 years old, so almost 500,000 years older, but the same species. Much bigger back then, interestingly. We're getting smaller mammoths here, but that's for another video. Anyway, this is steppe mammoth. I know it's a tibia from the shape, so that's the lower leg bone, the rear leg. But if we look at this end, this tells us that it was a juvenile. Quite apart from the size, this is an epiphysis surface. That's where the bone grows from, and the bone should actually be all the way out here if we had the bit that goes on the end, and it grows and knits together from this point. So it's a juvenile steppe mammoth. We can tell that much, which is pretty cool. But also, we know that this poor thing was not necessarily killed by spotted hyenas, but the spotted hyenas were devouring the bones. This scalloped edge here is classic spotted hyena chewing damage. And then we've got lots of tooth marks around here as well, where they were just chewing away on the bone.
So predator and prey.
Yeah, but it doesn't stop there. We know which way the bone was lying for quite a while on the surface of the ground before it got buried, because this side is quite different from this side. This side is in fairly good condition. Yes, there are cracks in it. We'll ignore that for the time being because that's happened after the specimens got buried. Look at these cracks on here. Like peeling paint on an old door, you get those feathery sort of cracks, don't you? This cracking here, that's classic UV weathering damage, ultraviolet from the sun. So know that the bone was that way up. And in fact, we know that the chewing is on that side as well, less so on the other side. So it was lying in the sediment that way around for quite a while.
Look at that. That's amazing. That is absolutely amazing.
So great to find a bone, but some bones have stories to tell.
Well, we have a very modern
this is
skull
a camel
here.
skull.
A camel skull.
Yeah, not from here, not from the UK.
I'm going to lift this up.
But this is a specimen in my collection because it's a good example of just what I've been talking about. This camel skull was clearly lying in the sand that way round. Okay, all this side was exposed, but this side wasn't. This is in lovely condition here, and actually, if we look at the teeth, you'll see the teeth are in brilliant condition on this side. It was buried in the sand. All this side is rotted. And that's simply from the weathering of the UV, and hopefully you can see that all this damage here, that's all on that exposed side. That's what the sunlight will do, and just weathering in general, changes in temperature, that kind of thing. That's the damage it will do to the bone.
That is that's a real cut and dry example, isn't it?
And with the West Fronton mammoth from Norfolk, we actually wrote a paper on exactly what happened to the mammoth from the point where it died to the point where it was completely buried, and that's to do with the weathering, how the bones been moved around by other mammoths, how the hyenas been gnawing the bones, pooing on the bones as well, which is great, and just how it ended up, the point from which an animal dies to the point at which it's completely buried is called taphonomy. Is what happens to the carcass, and it's so interesting to pick out all those details. And you can do it with a single bone to an extent, but when you actually have a fairly complete animal, and that was 85% complete, you can really go to town on it and figure out what happened in some detail.
So there really is a lot more to any site than just the bones.
Yeah, a lot more than meets the eye. But it's also what you don't find.
Now I love it when you say this, because this I think is really, really important and something that a lot of people don't think about.
So if you pass me the hand axe.
Right, I'm just going to very carefully put that there.
I'll talk about another site briefly, then I'll come back to this side.
So this is amazing.
So, this is a classic Neanderthal hand axe. There was a site at Linford in Norfolk that we found about 20 years ago. It's known as a Neanderthal mammoth butchery site. Now, we found, I think, 46 hand axes like this there.
46.
More importantly, we also found about 2,500 pieces of debitage from the hand axe. Now that debitage means all the removals of flint that you remove to actually make the hand axe. 2,500. So the hand axes were clearly being processed there, being made there for use on the mammoths that we found.
Because they have some good flint in Norfolk.
Oh, they have the best flint in the world in Norfolk. Oh, and yeah, it's amazing.
Because we do have, we found, I think it's 4 hand axes so far.
Yeah, 4 hand axes.
Not this year, but on the previous years at this site.
And it's an important signature of humans being around. But particularly in Norfolk, there was a debitage there, so we know that they were making them there. And there were up to, I think, 11 mammoth carcasses there. So it's I should say it's about 60,000 years old. That's mammoth, woolly mammoth that is, reindeer, woolly rhino, classic cold stage environment. But although we had 11 mammoths, not a single limb bone.
Okay.
There should be 132 limb bones, or up to, obviously not going to find all of them. But limb bones are massive. That's a small juvenile. You'd expect some limb bones to be this big. They're the very last things that would be destroyed either through weathering or through trampling. Something or someone removed them from that environment. We don't know why, but they're definitely not there. It wasn't the hyenas removing them completely, because there are plenty of other bones they could have removed. It'd be difficult for them to actually move some of these. So the Neanderthals, because it was Neanderthals at that point 60,000 years ago, must have removed these limb bones from site. Now it's a treeless landscape because it's so cold. They could have been burning them because you can sort of burn the fat. They could have been just using them to make rudimentary shelters. They could have been processing them for marrow, because there's a lot of marrow in these big limb bones.
Yes.
Certainly they must have been very important to them because they removed them all from site. Now, just a month ago, bear in mind this was 20 years ago we found this site, just a month ago there was a great paper published about Neanderthals processing marrow in, and I quote, industrial quantities.
Which you would get with that many.
Yeah, and
bones
so
that
almost
size.
certainly they were removing these bones from site. So the most important thing about that site in a way isn't the hand axes. We know Neanderthals make hand axes. We know about the decolletage. It's the fact that those bones weren't there. That shows you something about the activity of those humans at that time.
See, I just think that's a whole other way of getting your head round something, just looking at it from a totally different angle.
It relates to this site though in a way. Yes, we have hand axes from Neanderthals here. They may come from a bit further upstream. It's difficult to tell at the moment exactly the context. But forgetting Neanderthals for a moment, let's talk about hyenas and poo. Hyenas have been around, as I said, for about 1 million years in the UK, and they devour all the bones, but they won't eat the jaw bones, the lower jaws and the upper jaw bones of animals, because they'll break their teeth on their teeth, and they don't like the bovine horn claws, so bison horn claws, they leave those behind as well. So if you have a site where you seem to have more mandibles and teeth and more bovine horn claws than you'd expect given all the post-cranial material, that's everything in the rest of the body, then hyenas have been there. They've been devouring all those bones, but they just leave those bits that they don't like.
Oh, well, that's very interesting when you think what we're pulling out of this site.
Yeah, it's classic for instance, the chromophorus bed. We know you have hyenas there. The poo is everywhere. There's gnaw marks all over the bones, and you will generally find like mandibles and bovine horn claws and antlers actually more than anything else. So that's their signature in the landscape, and that seems to be what we have here as well. We've got quite a few horn claws, etc.
We do.
But not enough of the postcranial bones. So although you haven't found any definite poo yet, there's one or two that might be. We haven't found any hyena bones, but we have found some gnawed bones as well. That's the signature that they left behind. But even if we didn't have their poo, even if we didn't have their gnaw marks, the very fact that we aren't finding those postcranial bones in the quantities that we should do, given those other elements, the jaw bones, the bovine horn claws, they were here.
Ooh,
So again, it's what you don't find.
I think that's brilliant. I hope that's helped you. Well, basically, open your minds to an awful lot more than just the bones that we've been showing you and the other fossils and things, because this is just brilliant. This is detective work. It's just telling us so much, isn't it? And we're doing this a lot on a much smaller scale, because we're taking samples from around each find that gives us that insect information, that leaf information, whatever, the micro fossils.
And they're really important because a mammoth is quite large. It can live in a fairly wide tolerance of conditions, generally speaking. But your beetles and your other insects and the plants that they live on, incredibly narrow tolerances of maximum and minimum temperatures in the summer and the winter, etc. So taking samples to be processed under proper lab conditions to pull that sort of information out, the macroflora, the botanical bits, and all the insects and beetles, is some of the most important work we can do.
Well, we've found this as well with the Jurassic material.
Yes.
Because people have been breaking the nodule, and you've got wood. Wood that it's almost like it's only just been a couple of days sort of thing. Amazing wood, and this is a marine area. So this is wood that's come out from the land, floated down the rivers, and got out to sea, and then sunk.
And also, if you have something like a mosasaur or an ichthyosaur or a plesiosaur that lived in marine conditions, again, that tells you something. They were there. Again, they've got a broad range of temperatures, etc., that they can probably live in. It's the microfossils, the forams and the ostracods, that kind of thing, that you have to break down and look under a microscope and break down the matrix to see. Those tiny fossils will give you the age of that sediment with quite precision. Like the Rutland ichthyosaur is 183.1 million years old, I think, because of the microfossils. But they can also tell you water depth, whether it's sort of shallow coastal or more oceanic. It can tell you sometimes salinity and water temperature. From the microfossils, they give you a much finer resolution of data. They're really important.
See, that's what the important thing is. So you will see people moving up around each area, and they're collecting all that soil samples. In fact, on another video, we were actually talking to you down in there, and you had got these bags where you were collecting all that information. Do you know what, Nigel? Amazing.
My pleasure.
What an incredible selection of finds to talk us through and really bring them to life, because you know, it's not until you start pointing things out it becomes a little bit more obvious. So thank you so much for that, and really, really appreciate it. You're going to have to disappear now and do your other
I've
job.
got holes to dig.
Yes, you've got to go down there, enjoy your last couple of bits before you have to rush off on another job, and then you'll be back joining us towards the end of the week.
That's right.
Because this is a 3-week dig, and we are in week 1. We're only halfway through the first week, and this has just been amazing. Thank you very much for explaining all of this to us, Nigel. Really appreciate
my
it.
pleasure.
Thank you.